Today's video is about the inorganic chemistry and we are going to discuss the group trend today. First, I'd like to explain that what is a group trend. It is the variation in the properties of the elements that are located in the group in the periodic table. As it is a trend and trend means regularity. So there is a regularity in the properties of the elements. If there is irregularity or abnormality in the regular behavior or deviation from the regular behavior, it is called as the exception or anomalies. Talking about the atomic radius, it is the distance between the nucleus of an atom to its outermost electronic shell. Keep in mind that in the atom, you might have more than one shells, so the distance is from the nucleus to the outermost electronic shell, which means the last shell or the valence shell. For the group trend of atomic radius, we know that as we move down the group, the number of proton increases. That means the atomic number increases. As the atomic number increases, the number of energy level occupied by the electron also increases because electron reside in the energy levels. Since the number of energy levels are increasing, which means the distance from the nucleus to the outermost electronic shell is also increasing. As we move down the group, the atomic number increases, which means that the number of electrons are increasing. Where do electrons live? They live inside the electronic shell or they reside in the electronic shell. Therefore, the distance between the nucleus and the valence shell also increases, which means as we move down the groups, the atomic number increases. But there are few exceptions. What is the exception? That moving down the group, the atomic number is increasing, but instead of the increasing atomic radius, the atomic radii becomes smaller. And where do we have this exception? If we talk about the representative elements, it is in the P block for the group 3rd A. The parent element of the group 3rd A is the boron, so it is also called as the boron family. As we move from aluminium to gallium, the atomic number of aluminium is 13 and for gallium it is 31. You can see that the atomic number is increasing, so eventually the atomic radius should also have increased. But despite of the increasing atomic radii, the atomic radii becomes smaller. So it is an exception. And keep in mind that whenever you have an exception, so for every exception there must be a scientific reason for it. What is the reason here? That gallium has the slightly smaller atomic radii than aluminium despite being located below the group. Gallium is located below aluminium but still it has the smaller atomic radii because of the poor shielding effect which is caused by the electrons of d orbitals. I have also mentioned the electronic configuration for both the elements, aluminium as well as gallium. For aluminium, you can see that you have the outermost energy level, that is 3s2, 3p1. So here the s and p orbitals are involved. But for gallium, you can see that you have 3d10 and 4p. Here the d orbital is also involved. These d orbitals have electrons and these electrons cause the poor shielding effect. Eventually, because of this poor shielding effect, the atomic radius of the gallium becomes smaller than the atomic radius of the aluminium. This is the inorganic chemistry group trend and we have discussed the atomic radius. I have prepared it in the form of notes, so if you want, you can also note it down for your better understanding Make sure that you are watching the video completely to have the complete grip on the topic. We have other properties as well. For the atomic radius, now I'd like to ask you a few questions and you can also give me your answers or share your answers. So what is atomic radius? How do you define group trend? Why does gallium have slightly smaller atomic radius than aluminium? What is the group trend of atomic radius? What do you mean by exception? Why does increasing atomic number also increases the energy levels? Which orbital's electrons are involved in the poor shielding effect for aluminium and gallium? Write a short note on the group trend of atomic radius. So these are also the practice questions that I have also added in this video, and I'm also going to write it down in the description box so you can check it from there as well. This is the complete note for the atomic radius. This video is about the inorganic chemistry group trend. If you still have any question, feel free to reach out and I would be most happy to assist you with your queries. This is all for today. You can also write down the answers if you want. Thank you so much.